welcome again to a new video. And this time we are going to study the coupling beams. Now we are going to see what is the concept of this coupling beam, how a civil engineer is going to use this coupling beam in buildings, how it can be modeled, and what are the parameters that we need to understand while modeling this kind of the structural element. So let's dive in. First, let's start with what is the basic definition of, you can say, the coupling beam. Now see, these coupling beams are a kind of a structural elements which are going to connect two separate or individual items of your building. These individual items are generally going to be the shear wall. The shear walls are going to be joined by an structural element which is going to be known as coupling beam. These coupling beams are going to improve the lateral force resistance of a building. These are going to be kind of a very short and thick, and their characteristics is going to be like for deep beams. You can see into the diagrams onto the left hand side that there is a beam which is connecting to, you can say, the shear walls, and this beam is going to get failed in several ways that we are going to see after in this slides, that what are the kind of failures or what are the kind of plastic hinges that are going to get formed. So into the basics, if we are going to talk about, the coupling beam is going to be a beam which is going to bridge what? Two separate individual structural elements. And these structural elements are generally going to be the shear walls. Now, what is going to be done by this coupling beam is, this coupling beam is going to have two roles specifically. If we talk about the first role is going to increase the moment of resistance of that particular building. Now, it's obviously that if we are going to connect one shear wall to the another, the force is going to get transferred from one shear wall to the another one, and hence it is going to increase the moment of resistance of the whole, you can say, the building structure. Now, what is going to be the second rule? The second rule is going to act as a source of energy dissipation. At the time of earthquake, our building must have to be a bit of, you can say, flexible. The whole rigid portion is not going to help us. So these kind of, you can say, ductile deep beams which are going to connect these two shear walls, it is going to be a bit flexible. It is going to provide a bit of, you can say, a ductability to the structure, and in result our structure is going to be more resilient. So these are the two basic roles of coupling beam. The first is going to be the increase in the moment of resistance. The other is going to be it is going to be a source of energy dissipation. Now let's talk about the modeling parameters that we need to take care of when we are going to use this type of coupling beams. Now, the two parameters that we need to take care of are the coupling ratio and the length to span ratio. Now, what is going to be the coupling ratio? The coupling ratio is the ratio of the stiffness of the beam divided by the stiffness of the wall. It's a ratio. So onto the numerator, we are having the stiffness of the beam, and onto the denominator, we are having the stiffness of the wall. Okay. Now you can see it here, that is in model 1. You can see the beam is a very small in size as comparison to both the shear walls. Both the shear walls are highly reinforced, and we can easily conclude from this diagram that the stiffness of the beam is quite low. So the numerator is quite low. So the numerator is quite low. That means your coupling ratio is low. Now, onto the another hand, the next parameter is the span to depth ratio, or the length to height ratio of that beam. We can easily see in that model number 1, you can see it here, that the length is quite long as comparison to the depth. So that's, we can easily understand that L by H, or the span to depth ratio, is quite greater. So there are going to be the two criteria here. The first, model 1, that has been shown here, it is having a very low coupling ratio. As I have discussed earlier, the numerator is low, so the ratio of the stiffness of the beam to the stiffness of the wall it is connecting is low, so that it is having low coupling ratio. And the span to height ratio, that is L by H ratio, is greater than 4. We are assuming it is going to be greater than 4. So if it is going to be the criteria, then what is going to be done? The beam can be designed by the simple beam theory, and the plastic hinges are going to be appear at the end of the beams. It is going to be a simple behavior. It is going to be our conventional behavior. Now, if you talk about the model 2 and model 3 here, you can see that in model 2 and model 3 here, we can easily see that they are very less in the length. Their span is quite low. So that L by H ratio is quite less. It is not greater than 4. It is going to be less than 2. We can suppose it in this particular situation. And on the other hand, we can see here that in model 2, a cross bracing has been used. And in model 3, a hybrid connection has been used. So what is happening? The coupling ratio is getting bigger here. Okay, the coupling ratio is getting high. So the criteria 2 arises here, that in model 2 and model 3, the high coupling ratio and the span to depth ratio is, if it is less than 2, then we need to check, we need to do the finite element analysis, and we need to use the software, and we need to check where the hinges are going to get formed. Okay, so these are kind of two main parameters that you need to take care of while you can say designing or modeling this type of coupling beam. Okay, so the plastic hinges formation is going to be like that. I have told you earlier also. So if the beam is having a high coupling ratio, the plastic hinges are going to be into the middle. It has been seen from the researcher that is that the plastic hinges is going to form into the middle portion if it is having a high coupling ratio. And if it is having a low coupling ratio, you can design it or you can model analyze it with a simple beam theory, and it is going to be formed at the end of the beams. You can see under the diagrams also here that onto the high coupling ratio, the hinges are going to be in between, and in the low coupling ratio, it is going to be at the end. Now, one thing that we face here is the concentration of stresses here, or the singularity of stresses here. At the point of junction, where our beam is connecting with the shear wall, the stress are going to concentrate at that particular portion, and the failures can be there, the cracks can be developed here. There are many methods by which it can be prevented. You can detail the your anchorages detailing there. You can revise your anchorage details there. You can provide fillets there by bending the bars there. And there are many ways in which you can increase this topology. Okay, but this is the point. Okay, in any case, you are not going to fully avoid the stress concentration there, but you can effectively convert that singularity into the a bit of, you can say, stress concentration. The singularity can be avoided by this by providing fillets and all. Okay, now, so bottom line is, for the low coupling ratio, we can see here that the low coupling ratio is easy to make. Okay, it is very, you can say, it's a conventional form. It is most extensively used. It is easy to, you can say, construct. But however, it is not going to be very helpful for us in the high seismic region, or where we want high strength. Then the low coupling ratio beams are not going to be used there. But as they are easy to construct and they are very extensively used, so they can be used. On the other hand, if we talk about the high coupling ratio beam, these are the most effective ones. It are going to provide the ductile performance. They are going to give us the excellent energy dissipation capacity. It is going to have a very positive advantage. But there is a negative downside is there, the constructability issues. It is not easy to construct. We need a more skilled labor and kind of a things at that particular position. So what to do? Which one to use, the low coupling ratio or the high coupling ratio? Now, before jumping into that particular conclusion, we need to see the current trending research in this particular area. And that current trend, or you can say the research, talk about the hybrid coupling beam. Now, what are the hybrid coupling beams? These are being made up of from the steel section by using the welds and the bolt. They can be of many different type of, you can say, configurations. As you can see onto the bottom, there are top chord members of I sections, and they are been connected by the viscous dampers diagonally. You can see they are the box sections into between them. They are welded and bolted there. What is the advantage? The advantage is their reusability. After earthquake, the member is going to get dismantled and it is going to get used up again, or it is very easy to repair them. So these hybrid coupling beam are going to be very advantageous in that particular case. So now we have three options: low coupling ratio, high coupling ratio, and the hybrid coupling. Now, when to use which one and when to. So let's talk about the end notes here, that we can say here that not a single type of coupling ratio is kind of fitted for every kind of project. Okay, we can't say that a single type of coupling beam is applicable to all the, you can say, the building design. It totally depends on your economic situations, or you can say your loading conditions. We need to take care of all these things. We need to take care of the limitations associated with the anchorage requirement, with the local design code requirements, or you can say with the mainly your structural rigidity. Okay, so it depends on many situations. If the seismic capacity, or you can say if the seismicity of that particular area is quite low, you don't need that type of, you can say, strong coupling beams. You can go with the low capacity ratio, and for the other one you can go with the high, or if the stress is kind of very high, you can go for the hybrid ones also. Okay, So was my very short video on the concept of coupling ratio. I hope it was helpful to you. Thank you for supporting. If you have any further question, or if you have any further more topics that you want to know, please feel free to write down to me onto the strong Instagram and to the email address that I have shown here. The credits for all the data and material from this PPT goes to the Idea Statica software's blog. That software is used for the connection design. It's a very good software. I'm going to pin down the link of that blog down in the description. You can read out from here to have an more idea of this concept. Thank you once again. If you have any more question, please do let me know in the comments. Thank you. Bye-bye.